Hello everybody. In this video we are going to construct a 16 by 1 multiplexer with two 8 by 1 multiplexers using block diagram. This is problem number 4.31 from Digital Design by Moris Mano's 5th edition. Okay, let's get started. And this video consists of 7 parts. In this, the first one is the introduction about the MUX. Second one is giving the details about the pin diagram of 16 by 1 MUX IC, 8 by 1 MUX IC, and 2 by 1 MUX IC. In the third section, we have the block diagrams of all these three multiplexers, and in the fourth section we have the construction of the 16 by 1 MUX using 8 by 1 MUX and the 2 by 1 MUX, and this section gives you the direct answer. So if you want, you can skip all these other steps, first, second, third, fifth, sixth and seventh. But if you want to get a detailed explanation about this construction, then you can go through all these steps. Okay. The fifth one gives the working of the circuit constructor, and the sixth section gives the testing and verification of the circuit using sample input, and in the seventh we'll be comparing the working of the constructed circuit with the 16 by 1 MUX. Okay, let's get started. So first you should know what is a multiplexer. Multiplexer is a combinational circuit which has n number of inputs, a single output and m number of selection inputs. And we can get the n number of data lines or the input lines depending on the selection lines. If you have m number of selection lines, and then 2 power m will give you n number of data lines. That means you need n number of data lines for m number of selection lines based on this equation. And what is the function of the multiplexer? This multiplexer selects one input out of n number of data lines and transfers it to the output based on the selection input. This is also known as a data selector. And this is the second section in which we have the pin details or pin diagram of the 16 by 1 MUX. See, this is the IC 74150 which acts as a 16 by 1 MUX. So here you have 16 data lines, 4 number of selection lines and 1 output line. And here you have this 8 by 1 MUX in which we have 8 number of input lines. It starts here, right? This is your I0 first, I0, I1, I2, I3. Then here you have this I4, I5, I6, I7. This is your 8 by 1 MUX. This is your 16 by 1 MUX. And where is your output line? This is your output line. That Z represents output line. And other than that, we have the ground and the VCC. Then this 74157 axis with 2 by 1 MUX, but it consists of 4 number of 2 by 1. Okay, that is quad. So here you have I0 and I1. I0 and I1 as the input lines, and this is your output line for the first 2 by 1 MUX. Other than that, you will be having the B, I0B, I0B and I1B and ZB for the second 2 by 1 MUX. So we are going to use only one 2 by 1 MUX here. Okay. And here you see it is I0C, I1C and ZC. They form the third 2 by 1 MUX. And this I0D, I1D and ZD, it forms the fourth 2 by 1 MUX. Okay. And this is the block diagram which we need to construct the required circuit. So this is a 16 by 1 MUX. So it consists of the input lines or the data lines from 0 to 15. That means 16 input lines are there. And here we have the selection lines, and here you have this output line. Similarly, for 8 by 1 MUX, we have this I0 to I7. That means 8 number of input lines. And here we have this 3 number of selection lines and 1 output. So here this represents your input and this represents your output. Here this represents your input, number of inputs, and this represents your output. And here we have this two inputs and one output. Okay, so here this I0 and I1, these are all the inputs, and this selection line, and then here you have this output. So the third section is over, and now we need the circuit elements, that is two number of 8 by 1 mux, okay, and one number of 2 by 1 mux in order to construct this 16 by 1 mux. So actually what is the function if you look into this? So before constructing the circuit, we should know how a 16 by 1 mux works. Okay, then only we can perform this construction, isn't it? So here you have the 16 by 1 mux. So this works based on the selection input only. So it is a data selector. So you have 16 number of data available or the input available. Among the 16 inputs, you need to select only one input. Only one input will be selected and that will be transferred to the output side. That is the functioning of this multiplexer. So suppose if you give 0, 0, 1, 1 here, then what would happen? This I3 will be selected and that will be connected to this output side. And whatever be the data available at this I3, that means you may have a 0 as the input here, then that 0 will be available at the output side. That's it. Suppose if you have one input here, then that one input will be transferred. Okay, so that depends on the selection input. So all other remaining I4 to I15 and I0 to I3, that input lines will not be connected and that data will not be transferred. Only this I3 line will be selected. Similarly, if you have another, suppose here it is 1, 1, 0, 1, then what would happen? This 13th line, that would be selected and it would be connected to the output side, so that whatever be the input available at this I13, that would be available as output. Suppose if you have one input here at I13, that one input will be available. Remaining input lines will not be selected, they won't be getting connected to the output side. This is how this 16 by 1 mux works. That means depends on 4 inputs, 4 selection input bits. Okay. So suppose if you go for this 8 by 1 mux, this 8 by 1 mux works based on the 3 inputs here. Suppose if you are providing 0, 1, 0 here, only 3 selection inputs are here available at 8 by 1 mux. Based on the 0, 1, 0, this line will be selected and it will be getting connected to this output side, and the data available here, if it is 1, that 1 will be available here. If you are having a 0 at this I2 position, then that 0 will be available here. Okay. The remaining I0, I1, I3 to I7 will not be selected and it will not be connected to the output side, and no data from these input lines will be transferred. Okay. Then how is it possible for us to perform the functioning of this 16 by 1 using this 8 by 1? How is it possible? That's what we are going to see here. So we have the circuit elements and I'm going to arrange the circuit elements like this. So I'm going to have these two 8 by 1 mux arranged like this, and then I'll make the connection like this. This Y will be named as Y1 and I will be making connection with this I0 of this 2 by 1, and I named this as Y2, this 8 by 1 box, and it will be connected to this I1. Okay, and this S2 will be connected with this S2, and this S0 will be connected with this S0, and this S1 will be connected with this S1. Okay, all these connections we do, and this would be renamed as S3 because we need 4 number of selection inputs. Already we have here S0, S1, S2, and this S0 of 2 by 1 will be renamed as S3. And here we have only 8 inputs. Similarly, here also we have the 8 inputs, but these 8 inputs will be performing as I8, I9, I10, I11, I6, 12, I13, I14, and I15 of that 16 by 1 MUX. Okay, so the first 8 data lines access the first 8 data lines of 16 by 1 MUX, and these 8 data lines will be acting as the later part of this 16 by 1 MUX input lines. Okay, so now we'll have the proper connection here. So instead of having this connection at here, I'll make it here. This S1, S2 and S0 are tied together. So this is MUX number 1 and this is MUX number 2. And we have renamed this. But actually they are I0 to I7 of this 8 by 1 MUX, isn't it? I0, I1, I2, I3 and I4, I5 and I6 of this 8 by 1 MUX. And here we renamed this Y1, Y2 also, and this S0 is also renamed as S3. Okay, so if you construct this, definitely this would work as a 16 by 1 MUX. The whole circuit diagram now acts as the 16 by 1 MUX. So this is the answer for our problem asked in 4.31 of digital design. Okay, but we should know how it is actually functioning, isn't it? So if you just give this circuit diagram, that would be serving as the answer for the problem. But we'll see how it is actually working. So here we have this S3 to S0 as the selection input. So if you have 4 selection inputs, then 2 power 4, that means 16 combinations are possible. So it is ranging from 0, 0, 0, 0 to 1, 1, 1, 1. Okay. But I have actually given these, this S2, S1, S0 with the white color because they are the direct selection input for this 8 by 1 MUX. So I have given them in white color. But this S3, that would be the selection input for 2 by 1 MUX. So this MSB selection input is acting as the selection input for this 2 by 1 MUX. Okay. Remaining S2, S1, S0 are the selection input of this 8 by 1 MUX. That's why I have separated them and I have differentiated them using different colors. Okay. Now let's see. Suppose if you have this particular combination, for example, this combination is taken 1 1 0 0. So 1 0 0 is for here, right? 1 0 0. Which line will be here selected? This I will be selected and it will be connected here. And on this side, because of this 1 0 0, this one will be selected and it will be connected here. So you have two different lines connected here, and suppose if you have 0 input here and here you have the 1 input available, and this 0 input will be transferred here to Y1 and this 1 input will be transferred here to this Y2. So this I0 will be having 0, I1 will be having 1. But what about this S3? S3 is 1 here, isn't it? So S3 is 1. Because of this 1 at the selection input, I1 will be selected and it is connected here. Okay, so you will receive the output here as 1. So actually which one is getting the connection? This 12, I12, because this corresponds to 12, isn't it? 1100 corresponds to 12. So that 12th data line is connected here. So you will be receiving this 1 from here, isn't it? So this is, even though this is getting connected using this 8 by 1, it is not being connected because of this S3 selection line of this 2 by 1 MUX. So we'll see another one example. So here suppose this 0111 is taken as the selection input. So here you will be having 111, and here this will be having 0. Because of this 111, I7 is selected and it is being connected. And here this I15 will be selected and it is connected to the output side. And suppose if here you have a 0, here also you have a 0, this Y1 will be equal to 0. Here we have this connection here, right? So this 0 will be available at the input side, and this 0 is also available at the input I1. But because of this S3 is equal to 0, this I0 line will be selected. So this data will be transferred here as the output. So this data is not being connected. This data is taken and transferred to the output side. Okay, this is how this particular circuit works. And this is again how, with the sample input I have given, how it is being working, and we can test it. Already I have explained you. Anyhow, for all these inputs we can test this using this selection inputs. Okay, we start with this. If you want you can take it or you can skip it. Okay, 0000. So here it would be 000, and here this S3 is 0. So this line will be selected, this line will be selected, and both will be connected here. So that here we have the input at this I0 as 1, so Y1 is equal to 1. I8 is equal to 0, so Y2 is equal to 0. And because of this 0, this I0 is selected and it is being connected. So this 1 will be transferred here. So the output is equal to 1 in this case. For the first case, output is 1. Then we go for the second input, selection input 0001. So 001 here, and it is 0 here. So this first line will be connected, and this ninth line will be connected here. So this 0 will be taken and it is transferred to Y1, and this 0 will be taken and transferred to this Y2. But S3 is 0, so this I0 line is selected, that input 0 will be transferred. Okay, so you receive this 0 for this selection input. And we go for another one. Suppose if we are taking this 1011. So 1011 means 011 will be taken here, and S3 will be 1. This S3 will be 1. So that's for the 011, this line will be connected, and here this one will be connected. So this input I1 will be transferred, I3 equal to 1 will be transferred here. This 1 will be transferred here, and for this also 1 will be transferred. But this S3 is 1, so I1 will be selected here. So this 1 will be transferred here, and you receive a 1 here. So this value will be 1 when you give the selection inputs as 1011. And we try out with another example, another selection input. Let's take this 1000. Okay, so it is 000 here, and for S3 it is 1. So 000 means this 0th line will be selected again, because for this input also It is 0, 0, 0. Okay. Here also this 0th input line will be selected. I8 it is. Okay, it is selected. So that this 1 will be transferred here. Here this 0 will be transferred. But this S3 is 1, isn't it? So this I1 is selected. I1 line is selected. So it is getting connected to the output side. So this 0 will be made available at the output side. So for this case, you will be getting a 0 at the output. So this is how it's working. And if you want, you can compare it with the 16 by 8, 16 by 1 MUX also. So if you want, you can do the comparison. So we give the same data here. Here it is 1011. Check here it is 10110111. Similarly, the same data is applied here 10110111 up to this 8 data lines. Similarly, the remaining it is 0011. Here also you have this 0011. Then here you have 0000. Similarly, here you have the 0000 for the MSB bits. Okay. So same data is applied. We are going to give the same selection inputs for both the multiplexers. For the 16 by 1 as well as the one which we have constructed. This is the circuit we have constructed. Okay. Which is actually for the purpose of the 16 by 1. Okay. This case will take 0011. Okay. So what it is being applied here 0011. So which one will be selected? The third line will be selected, isn't it? This I3 will be selected. So that line will be connected, and so you'll be getting the output as 1 because the input is 1 here. Here you see the same thing, right? So 0, 1, 1, and here yes, 3 is 0. So because of this selection input 0, 1, 1, this I3 is selected and it is being applied here. It is being connected here. And here also this I11 is selected and it is being connected here. So what is the output? For this Y1 is equal to 1 because of this 1. And this I11 is also 1. It is also coming here as Y2. So here I0 is equal to 1. This I1 is also 1. But this S3 is 0 because of this I0. This line will be selected and it is getting connected here. So this one will be transferred and you will get it at the output side. So this one is coming. If you retrace back, it comes from here, isn't it? It is from here, this path, it follows this path, and it follows here. So it is from this I3 we get this output. Here also it is, if you retrace this path, it is coming from this I3 because of the selection input as 3. So we are going to give 0, 1, not 1 as the selection input. So here it is 1, not 1. Here it is 0. Here also it is 0, 1, 0, 1. So which one will be connected? The fifth line will be connected. So because of this fifth line being connected, this one input will be transferred here as the output. That's it. We received the output. But when you come over here, this 101 corresponds to this I5 line. So it would be connected here. So this one will be connected to this. This one will be supplied at the output Y1. And here, this is I5, isn't it? So I13 is equal to I5. So this I13 will be connected to this Y2. So this 0 will be made available here. It is also coming to this second level. Okay. So this I1 is equal to 0. This I0 is equal to 1. This S3 equal to 0 because of that this I0 line is connected to this Y. So this 1 at I naught will be transferred here. So this y is equal to 1. So if you trace back this one at y output line comes from this I naught line. This I naught receives this one from this y1, and this y1 receives this one from this I5 line, where I5 line is having 0. So this 0 is being, the I5 line is having this 1. So this 1 is being transferred to this output side. Whereas this I13 line is not being connected because it is being blocked because of this S3 line, isn't it? S3 line selects only I0, not I1. So up to this point, the 0 is available. But after that, it is not being connected, isn't it? So we get the same output. That means I5 line alone is being connected. Here also this I5 is connected. Okay. So if you want, we can go for one more. So if you take this 1001, so here it is 001 and here it is 1. Here also it is 1001. So that means ninth line will be selected. Ninth line has the data 0 that will be transferred here. So the 0 is your output. So this is how the 16 by 1 MUX performs. So we'll verify whether our constructor circuit is performing similar to this 16 by 1 MUX. So because of the 001, this first line will be, I1 line will be selected and it is connected here. And this 0 will be transferred. Okay. And 001 means here it is I0, this is I1. So this I1 line that is equal to I9, isn't it? This I9 line will be selected and it is being connected to Y2. So this 0 will be transferred. So I0 is equal to 0 because of this Y1. I1 is equal to 0 because of this Y2. Then this S3 line is 1 because of this 1. I1 will be selected and it is connected to Y, final output. So it transfers this input 0 to this side. So you get the output as 0. But if you trace back, this 0 is not coming from here, isn't it? It is not coming from here. How? The 0 is being, this Y is being connected to I1. This I1 is being connected to Y2. Y2 is being connected to this I9. Because of this I9 which is having this 0 input, that 0 input is made available at the output side. Okay. So both the circuit are performing the same. So what we have constructed is correct. Okay. So hope you have understood. Thank you.